You're in my frame. Sorry. Hey guys, I really hope you had a great summer. And for all of you who are going into your second year of IB like I am, you might find that with your extended essay and all your coursework you have to do, it's kind of crushing and a little bit soul destroying. I'm kidding, I'm fine, I'm not dying at all. With the coursework it can kind of be difficult because if you're like me, I've never done coursework before, I literally had no idea what to do. But I thought I'd do a little thing about how to set up your biology IA because there's not really many examples out there that you can do it about. Or if you're going into your first year of IB right now, start thinking about what you want to do for your coursework right now. In any case, it's like, don't copy my idea, but I did experiments with enzymes. So I heated them up and then saw how they changed around a bit. I don't like explaining it because I don't really understand it.
I really understand it, but I really don't like talking about it because it makes my life so much harder. I'm having issues, can you tell?
In any case, I thought since there's not really much help really structure-wise what you can do with your coursework, I'm not going to give you ideas for your coursework, but just remember when you're thinking of ideas, you have to come up with your own experiment. So you can't use an experiment you've done in class, you actually have to come up with your own experiment. Have fun, good luck! Louise just said that you can do something that you pretend like you don't know much about, so you have a general idea of how they work. She did ethanol and yeast in. Hi!
Special visitor to the video. I did something about is ethanol toxic to yeast? But I already knew that ethanol is toxic to yeast, but I pretended like I didn't, and that's what my IA is about.
Just crawled up here like a little grudge or a little kid from The Ring. So at the beginning of an investigation, you might have a title, or you might just have your question. I personally just have my question. Straight under your title or question or whatever you decide to choose, you're gonna have your personal interest, and this is kind of what got you interested in the topic, and I'm gonna be bluntly honest with you, most of it is made up. You find out your investigation, you do the question, you do the method, and then you say your personal interest. It's a story. You make up a story. If you actually genuinely have a personal interest in whatever subject you're doing, kudos to you. You're a better person than I am. After the personal interest section, you have like a little background. So like for me, I had enzymes, so I put a little section on denaturation and enzymes, and you have a reference there. BioNinja is a great one. And then I had a smaller section on like biological washing powders and what they did, what they were in, and why they had enzymes in them, stuff like that. Right under your background, you're gonna have your variables, and then it's gonna be your independent variable and your dependent variable. And I recommend what you're doing is you state your independent variable, so like temperature, and then right under that you say temperature, the enzymes will be preheated to 20 degrees, 30 degrees, etc., etc. And then for your dependent variable, what you're measuring, and then say under that the units it'll be measured in, so that it's really clear and concise. You really want this to be laid out frank. It's like you were handing it to a 5-year-old and saying, here, read this, and they have to understand it. Under your independent and dependent variables, you're gonna have your controlled variables. This will be stuff that makes it so it's fair testing. And that can be whatever, it can be the temperature of the room, it can be whatever enzyme you used, whatever. It's easy to think these things up because it's stuff that you didn't change throughout the entire experiment. It could be your equipment, but under those, when you state your controlled variables, so like time or something, you have to do another little bullet point under that explaining that controlled variable and why it had to be controlled. Under your controlled variables, you're gonna have your hypothesis, and I recommend having a hypothesis and then a null hypothesis. Your hypothesis, I was always taught it's if, then, because, but really for this one, it's if and then. So if da-da-da is changed, then da-da-da-da will be impacted. And then under that section, you'll have to do a little explanation for that. Since enzymes like denature at higher temperatures, blah. That is your hypothesis. You have to explain your hypothesis. And then your null hypothesis is doing this and this will have no effect on the dependent variable. Under your hypothesis, you're gonna have your materials section. And after every single one of your materials, if it was used to measure something, you're gonna wanna have an uncertainty. Those are really important. If you don't have those in, you're gonna get points deducted off because you need to acknowledge that, yeah, there might be some error in this with the equipment. Then you're gonna have your procedure. Under your procedure, you're gonna have an overview, and that's basically just what the entire procedure is. And then you're gonna take them step by step through your method of how you got this procedure done. If it took more than different steps, like setting up the enzymes, setting up whatever thing you were using for temperature, do that in different steps so that it's really clear and concise what you did. Under your procedure, you're gonna have results. And that's where your awkward tables are gonna start coming in. You're going to have your raw data results, which is just what you measured straight off the bat. And that's gonna go into an appendix because no one wants to see your raw data results. So you're gonna say, for raw data results, see Appendix 1, Section A. And then under that, you're gonna have your process data results. And this is just gonna be your temperature, the mean, difference in whatever, and then standard deviation or whatever else you had to use for that. And then after you've shown your results and stuff, your processed ones, then you're gonna have your discussion. That's discussing the results, anything that might have gone wrong with the results. This is also where you're gonna be discussing your graphs. So you're gonna make your graphs, however many you need, however many tables you need. And so you're gonna discuss your results, anything that might have gone wrong, and then you're gonna talk about your graphs, what your graphs show, whatever you're trying to prove. And then you're gonna have like a reference where you found your information. So like for me, I went on a site and I found something that was like, these 2 enzymes that you've used have an optimum temperature of blah. And then you put that in and you say like, upon analyzing the data, it is clear that da-da-da-da-da-da-da. Okay. So after you've compared your results to the references, then you can say like, it agrees with this, it disagrees. If it agrees, then it's like, oh, well, yay, that's good. But if it disagrees, which is much more interesting because you have more to talk about, then it's like, oh, well, here's why it could have disagreed. My results personally disagreed. Now I need to explain it. Okay, and then under your discussion, you're gonna have sources of error. These, again, are very easy to find. You can do like uncertainties with measurement. This could have affected the dependent variable, da-da-da-da-da. And I set my sources of error up in a table. You might not want to do that, but I did because it helped me organize my thoughts. So in my first column, I had sources of error, and this is just what the error was. And then I had type of error. Can have a systematic error, a procedural error, or a random error. And then in your third column, you can have significance, so it can be a major error or a minor error. Then you have the explanation of your error, and that's like what the error was, and then improvement, so how you can improve on your error. Under your sources of error, you're gonna have your anomalies table. And your anomalies are just things that kind of went a little weird with your data. So when you're looking over your data tables and you see something that's not really like your other tests, then that's an anomaly, and you're gonna have that section after your sources of error. And then after that, you have your conclusion, and that's kind of just after taking into consideration all the sources of error, the data is still reliable, or it could be unreliable. If it's unreliable, though, I don't recommend saying that because that basically means your entire experiment is wrong. And under your conclusion, you're gonna have your further work. And your further work is like, well, here's what I did, here's what could be investigated later. So it's like a separate experiment that you might do in the future to improve the experiment you did now. But then after that, you have all your appendices, which is all your tables and your graphs. So that's the basics of how to set up a biology IA. I hope this helped a little bit. Hope this helped. Hope you now have a better idea of what to do with your biology IA. Peace, guys. Enjoy IB.